Hey guys, so these are your flip notes for acids and bases and pH. So the pH scale is a measurement system to indicate the concentration of hydrogen ions in a solution. When you're looking at the scale, if there's a 7, it's neutral. Lower than 7 is more acidic, and higher than 7 is increasingly basic. So the scale goes from 0 to 14, 7 being in the middle, where it's neutral. Water is neutral. It's a 7. Some acidic things, battery acid, the most acidic rainfall ever recorded, stomach acid, these are all really acidic or highly acidic. So the lower the number, the more acidic. Between 4 and 5, this is the range of which most fish will die. Looking at the basic substances, human blood is about 7.4. Baking soda, milk of magnesia, that's something you take for your stomach, so Tums, things like that would be in this area. And then household ammonia and cleaning supplies are all basic things. They fall between 10 and 12. So the important thing here is lower number, you have more hydrogen ions, and you're more acidic. Higher number, more hydroxide ions, more basic. And up here, if you look, the hydrogen ions and the hydroxide is OH minus. Again, just some more examples. Hydrochloric acid, stomach acid, lemon juice, they're all acidic. Basic, seawater, baking soda, household ammonia, oven cleaner, soaps, detergents, these would all be down here. Looking at the scale, it's a logarithmic scale, which means it's base 10. So if you look at the exponents here, they're all increasing by 1, but that's 10 times. So if you're 1, you go up one number, it's times 10. So then 10 times 10, 100. 100 times 10, 1,000. So these increase by 10. When you're looking at a definition of an acid, it's a solution containing a higher concentration of H plus or hydrogen ions than pure water and has a pH value below 7. You could also say that acids are bitter, but most of the acids we're going to deal with, you're obviously not allowed to eat them, so we don't eat them. But if you think lemons, when you eat a lemon, they're bitter. And examples, again, acid rain, tomato juice, lemon juice, stomach acid, and battery acid. A base is a solution containing lower concentrations of H plus ions than pure water and have pH values above 7. These taste bitter. If you've ever had soap in your mouth, it's bitter. Examples of bases, again, seawater, soap, ammonia, bleach, oven cleaners. And pH is important to us because most cells in the human body have to stay in a range of 6.5 to 7.5. We said blood was 7.4. And if that drops to 7.0 or rises to 7.8, so if it becomes 0.4 more acidic or 0.4 more basic, that's actually enough to kill you within several minutes. Some reactions speed up depending on pH, so if the pH isn't stable, the reaction will happen too fast or it can't happen at all. Looking at external pH changes. If there's acid rain, we know that affects living things. Some plants need to be in a more acidic condition, but a lot of them are not adapted to deal with a pH change. So if there's acid rain or the pH changes too rapidly in soil, the plants will die. In our body, like I said, if it changes 0.4, that's enough to kill you. So there are things called buffers. A buffer is a chemical substance that neutralizes small amounts of either an acid or a base solution. So this, when a reaction is going on, it helps the pH stay more stable or not change. This is important because when we're looking at enzymes next chapter, they can only work in a very narrow pH range. So if the pH changes, the enzyme is going to be destroyed and the reaction can't catalyze. Different parts of the human body have different levels of acidity. So your stomach acid is much more acidic than your blood. So obviously your body then needs to be able to control the pH. And again, it does that using buffers. When you're looking at the dissociation of water or the breakdown of water, when you're looking at a base, this OH is a base. The H2O breaks up to H plus and OH minus. You can also look at this as hydronium, which is H3O plus, but we're gonna focus on this one, so ignore this one. Acids contain more H3O than OH, so we're just gonna switch that to H plus. So an acid contains more H plus, and bases contain more O minus. These little brackets here, that means concentration. So if the concentration of H3O plus, the hydronium, or if H plus equals the concentration of OH minus, so if you have the same number of acid as you do base, the solution is neutral. So this is a 7 on the pH scale, and that's what water is. So overall, when you combine buffers with acids or bases, that's when you have water forming, or when the H plus and the OH minus are equal. And this, we have the water and a hydrogen and a hydroxide. We've got the ions going together, they're making water. This is not really something we need to focus on too much. You do need to know which entity, which ion is acidic and which is basic. So again, the H plus, the acid, the OH minus, the base. Okay, that's everything.